So everybody's right here at the same spot with me? Everybody understands y equals a times b to the x minus h plus k, and we're not even doing the minus h in algebra 1, that's for algebra 2. But we all understand this setup, right? We understand that a is just a number, b is just a number to the power of x, and then plus or minus a number out here at the end. Yes? Let me ask you this. On this example, what's your a value? 1/2. What's your k value? -4. What's your b value? 3. All right, we got it. We at least know where a, b, and c, or a, b, and k are at. So today we're going to be introducing exponential decay functions. Yesterday we did exponential growth functions. Today we're doing decay functions. So you determine whether it's growing or decaying, shrinking, from left to right based on your b value, which is the growth factor. If your b value is greater than 1, it's going to be growing. If your b value is less than 1, like a fraction that's less than 1, it's going to be decaying. So, for example, let's go back to this example. Is this going to be a growth function or a decay function? It's growth. Why? Because 3 is bigger than 1. It's this simple. If you take any number and multiply by 3, it's going to get bigger. What's 5 times 3? It's 15. It got bigger, right?
By 0 equals 1.
No, I'm talking about just the base. So the base, if the base is greater than 1, it's going to grow, no matter what. If the base is less than 1, like a fraction less than 1, it's going to shrink. So 2 is greater than 1, so it's going to grow, right? So let me prove it to you. If I had a fraction 3/4 times anything times 100, right? This 3/4, is it greater than 1 or is it less than 1? It's less than 1, so it's going to shrink. It's going to make that 100 turn to a 75 if you did it on a calculator. It's going to shrink, right? So knowing that if the base is bigger than 1, it'll grow. Knowing that if it's less than 1, it'll shrink, you'll know the difference between exponential growth functions and exponential decay functions.
So if the fractions, they're less than 1.
If it's a fraction that's less than 1, it's going to decay. But then again, you could have a fraction that's greater than 1. So let me give you an example of that right here. Y equals, let's say, I'm just going to put a base 3/2 to the x power minus 7. Okay, right there, what's the a value on that red one? What's the a value? There, a 1, right? There is no a value, so you say there's a 1. You can't say 0 because 0 would make it all 0. 0 times that would make it all 0. But it is 1. The base is a fraction, but is that fraction bigger than 1 or less than 1? What is 3 divided by 2? What's half of 3? 1.5, right? 1.5. So that's greater than 1. That will make it grow. So that would be a growth function. Make sense? So just because you have a fraction, don't think, oh, that's decay. Because if the fraction itself is worth more than 1, if it's greater than 1, then it's going to cause it to grow.
When it's an improper fraction, it's greater than 1. But when it's just a fraction,
there you go.
it's less.
So if it's an improper fraction, yeah, it's going to end up being greater than 1, which is going to cause it to grow. When it's a fraction that's less than 1, then you know it's going to be a decay function. Now, I know we haven't even seen examples of that. Let's move on back to the notes. What I just explained right there is kind of what I tried to explain right here in this little paragraph, saying that if your base is less than 1, it shrinks. If it's greater than 1, it grows. Then I give you an example. See, this one right here has a base that's less than 1. That's 1/2. So because the base is less than 1, this is a decay function. From left to right, it's going to shrink, right? It's going to infinitely approach 0. Now this base is 2. That's greater than 1. So from left to right, it's going to grow. It's going to grow to infinity, right? And yesterday, on yesterday's notes, we had definitions right here. It said definitions, right? But right here it says tips, not definitions. So we already should know what a domain is. It's the x values. But right here it's just the tip, how to actually answer. When they ask you for the domain on an exponential growth or decay function, your answer is x equals all real numbers. And you could write it like this, x equals all real numbers. An asymptote, We already know that that's the line, the horizontal line that your graph will infinitely approach, but that's not the definition right here. Right here, I just give you the way to actually state your asymptote quickly. Make sense? So if I asked you, what is the asymptote of that red equation right there? The asymptote would be, and give it to me as an equation, y equals -7. That would be the asymptote. It's simply based on the y value. Make sense? And that'll be the line that your graph will infinitely approach but never actually touch. The range, this is not the definition, this is a tip. Y is either going to be greater than the k value or less than the k value. It's going to be either above your asymptote or below your asymptote. Okay? And then another little tip, for the y-intercept coordinate, of course, you set x equal to 0 and you find out what your y value is going to be. But you could simply do a plus k. That'll instantly give you your y-intercept. Or you could actually look at it on the graph and see where it crosses. Okay, so I did make some steps here to graphing a growth or a decay function. Try to make it a little more organized for you guys. And I do start with step 0 to identify your asymptote y equals k, the horizontal line that your graph will infinitely approach but never touch. So if I take a look at this equation, this first example down here, what is my asymptote? So the asymptote is y equals -2. That's going to be the horizontal line that our final graph is going to infinitely approach but never actually touch or cross. Okay? Now that was step 0. Let's actually move on to step 1. It says ignore h and k, make an xy table, use consecutive integer inputs. Now when I say ignore h and k, I usually just do this. I put a box around the first part. I ignore the k value at the end. There is no h value. That'll be in algebra 2. So let me make a quick xy table and let me plug in some consecutive integer inputs. And after doing that step, if we go back up to the steps, it says use the easiest x value of 0 and get the output, which should be a. When you're ignoring k and you plug in 0, if you had an a value, that would be your output. Or you could just do the math. Do the math. Check it out. Plug in 0 right there. What's 1/2 to the 0 power? The answer is 1. So let's put that 1 right there. So for the input 0, we got the output 1. Now let me plot that point 0, 1, which is right there. And now I could continue to plug in the 1 right there and work it out. 1/2 to the 1 is 1/2. Or I could use my growth or decay factor. Remember the b value, the base, is the growth or decay factor. And that'll save you some time from doing math. What do I mean by that? You could take this output of 1 and multiply it by 1/2, because that's the decay factor, right? That's the base, which is less than 1. That's how I know it's decaying. So I could say 1 times half, and what do I get? What's 1 times half? 1/2. And then I could take that 1/2, and what do I could multiply it by half again. And what will I get? 1/4. And then the next one? 1/8. And so on and so on. See how that's pretty easy? And now backwards, because this was 1/2, as you go in the normal direction of counting, 0, 1, 2, you're going times 1/2, times 1/2, times 1/2. Or you could think of it as divided by 2, divided by 2, divided by 2. Now going backwards, it wouldn't be dividing by 2, it'd be what? It'd be multiplying by 2, right? So 1/8 times 2 really is 2/8, which reduces down to 1/4. 1/4 times 2 is really 2/4, which reduces down to 1/2. 1/2 times 2 is 1. So what's the next one up here? What's the next one up there? 2. And the next one? And the next one? See how it's pretty easy to use that growth or the decay factor? Okay? It takes practice. You can't just, you might be understanding me right now, but if you don't practice on your own, you're not going to be able to get it. You got to practice. So let's graph these coordinates. Let me go for the next coordinate, -1, 2. -1 on the x, 2 on the y is right there. Let me go to the next one, -2, 4. -2 and 1, 2, 3, 4 is right there. Let's go to the last one on the far left, -3 and 8 way up here. And we know it's decaying from left to right. We know it's shrinking, shrinking, shrinking. And we know it's going to infinitely approach what on the parent graph? It's going to infinitely approach nothing. It's going to infinitely approach 0, right? Look, 1, 1/2, 1/4, 1/8. The next one would be 1/16, 1/32. It gets closer and closer to 0. So I could graph it 1/2, 1/4, 1/8, 1/16. You can't even tell the difference anymore. We know that this is the asymptote of the parent graph. But remember, you don't want to graph the parent graph. You want to graph your final graph, which has to include the k value of what? -2. So what does that -2 actually mean that you're going to do with this graph? These red dots. What are you going to do with these red dots? You're going to bring it down. How many units? 2 units. The k value is -2, which means you need to move all these coordinates down 2 units. I need to take this one up here, move it down 2, and put a dot right there. I need to take this next point right here, move it down 2 units, and put a dot right here. And so on and so on. Now, again, why did I identify the asymptote right from the start, from the whole thing? We said y equals -2. That way you could have an idea, or you could specifically know your asymptote of the final graph, which is right here, y equals -2. That way, once you see that it's from left to right decaying, it's getting smaller, it's getting smaller, it's getting smaller, you already know it has to infinitely approach this asymptote. And you're going to draw it like if it's actually touching, even though you know it never touches, it just infinitely approaches. So your blue graph is the final graph that you want, the exponential decay function. That red one, I would put 2 x's right there, so I know that that's not the graph you want to represent. So there's a graph. All we need to do is answer everything that we can about this thing. The domain, and up on the tips, I tell you that the domain on all of these are going to be what? All real numbers. The range, that's your y values. Now y is going up and down, so this whole graph is going to be either above a certain value or below a certain value. So what do you say? Is it above or below? It is all above. What's the certain value? What certain value is it above? Yeah, -2's right here, and it's all above that value. Does that make sense? So we know that this graph is above the y values of -2. So how do I represent that as an inequality? Y is greater than -2.
Wait, I thought you always had to put it to 0.
And of course, the asymptote, that's what we originally started with. We knew that it's simply y equals k, which is -2. And the y-intercept, there's many ways of getting this, especially after you graphed it. One way is to actually look at the y-axis and see where it crosses. Oh, it crosses at the coordinate 0, -1. Or you could also use the tip that I gave you, which is 0, and then over here this value is going to be a plus k. Again, let me repeat that, 0, comma, a plus k. So the a value is 1, the k value is -2, so if you go 1 plus -2, you get -1 as an answer. So it's up to you if you want to see it visually, crosses here at 0, -1, or if you want to remember the little tip I gave you up on top of this paper, it says 0, comma, a plus k. A is 1, k is -2, 1 plus -2 is -1. Let's do another example. And you know what? I modified this paper from yesterday's notes and I made a lot of typos. You could just scratch out that stuff and let's just jump to the example. So what's the first thing that we could automatically do? Step 0, the easiest thing to do. The asymptote, which is down here, asymptote. Now what would the asymptote be? It's the k value. Remember, y equals the k value. And what's the k value here? 0. There is no k value. If you want, you could show it by putting +0. But we know that the asymptote is y equals 0. And you might as well draw that asymptote. So in other words, we know that there will be no shift. We're not going to be moving up. We're not going to be moving down because there is no k value. It's 0. So we know that that's the asymptote right there. Y equals 0. We know that our graph is either going to infinitely approach, it will infinitely approach this asymptote, but it'll never actually touch it. So step 1 is to make an XY table with nice consecutive integer inputs. And we're not going to use all these coordinates. Definitely not. So I'm going to plug in the easiest one, which is 0. And on our tips, it says that when you plug in 0 into your parent graph, if you don't have an h or k, it's going to be a, your output. So if you do 1/4 to the 0 power, that's 1. And 1 times 8 is 8. So when I plug in 0, I get out an 8. Are you with me? Now from there, you don't have to plug in any more numbers. If you want to, you can, but you don't have to. Now what do I mean by that? with the growth factor, or in this case, decay factor. What is this, growth or decay? It's decay. Why is it decay and not growth? It's less than 1. 1/4 is less than 1, which is going to cause it to shrink. If you get any number you want and multiply it by 1/4, it'll make it smaller. Right? So it's definitely going to be a decay function. So I could use this decay of 1/4 to get my next output. If I take the 8 and multiply it by 1/4, and you could use a calculator, of course. Now, multiplying by 1/4 is the same thing as dividing by 4, right? 8 times 1/4, that's 8 divided by 4, that is 2. And then 2 divided by 4, what's 2 divided by 4?
1.
Think about that. 2 divided by 4, that reduces down to 1/2, right?
Yeah.
And then 1/2 divided by 4, that's really like multiplying by 1/4, that's 1/8. Now, you don't even need, honestly, guys, you don't even need these guys right here because you already know it's infinitely approaching 0, right? So why do we do it? Just so you get more knowledge. That's why we're doing it. Now, in the opposite direction, if from here to here you're dividing by 4, dividing by 4, dividing by 4, going backwards would be multiplying by 4, multiplying by 4, multiplying by 4. So what would the next one be? 32 when you multiply by 4. Now, you're not even able to use that. So I'm not even gonna use it. I'm not even gonna continue because it's pointless, right? So let's graph what we have. Let's go to 0, 8. 0, 8 is up here. Let's go to the next one, 1, 2. 1, 2 is right here. And then the next one, 2 and half. 2 and half would be halfway up. It would be right there. So we already know that from left to right, this is going to infinitely approach what? 0. So you're just going to draw it like if it's actually on 0, but you know that it never actually touches, just infinitely approaches. Put another arrow right there, and we've graphed it. And now let's answer whatever we could answer. The domain, super easy. Domain is x equals all real numbers, all the time. Now, why is that? Because the graph will go to the left forever. Even though it curves up, it still exists at -10. I could plug in -10. I'll get a huge number way up here somewhere off the screen. So it does exist to the left and to the right forever. That's why we say x equals all real numbers. That's the same answer for any exponential growth or decay function. Now, how about the y's? Y is what? Where's this graph at? Is it above or below a certain value? Above what value?
0.
So what do we say? Y is greater than 0. And for the y-intercept, ladies and gentlemen, the y-intercept, you could think about the tip I gave you, which was 0 and then a plus k. The a value is 8, the k value is 0, so 8 plus 0 is 8. Or, since you already graphed it, you could just see that it crosses right there, and that coordinate is 0, 8. It's up to you. We're going to skip this one because it does require for you to multiply and divide by fractions. So we're going to keep it easy. We're going to flip the paper over and we're going to start on our homework on the back side. I want to continue that on a separate video. I'm done here. Hopefully you guys understood it.